Hello there and welcome to video number 36. This video is on calculating using limits of accuracy. The keywords I've got for you: limits of accuracy, upper bound, lower bound, described in the error intervals video. If you haven't yet watched the error intervals video, you will need to in order to understand the stuff in this one. So upper bound is the largest possible number that the rounded unit that you've been given in the question could be, and the lower bound is the smallest. Discrepancy is the error interval itself, so the range of answers that you could be giving, and these two words are types of data. Now, discrete data is stuff that can be counted, all right, fixed, and continuous data is something that can be measured, data that can be measured, numbers that are infinite, that will go on forever to infinite degrees of accuracy. You could be measuring them. Now, in the method, we are saying that we can find the upper and lower bound for the measurements in the question, not always necessary to find both. In the second step, we would do the appropriate calculations depending upon what the question is asking you, with the upper and lower bound values if you need to do both, and then you do the representing in an error interval if you need to, if you've been asked to at the end of the question. Now, the length of a rectangular piece of card has been rounded to 21.5 centimeters to one decimal place, and the width has been rounded to 13.4 centimeters to one decimal place. Just missed off the centimeters there. What is the upper bound for the area of the card? Now, what we should know already is how to work out the area of a rectangle, which is pretty simple: length times width. And then what we're going to use is the upper bound of each of the numbers. If we took the biggest number and multiplied by the biggest number, we would get the biggest area. So we're going to get 21.5, and then we're going to say that the upper bound of that. But if we think of it as 21.50, we could get it easy if we go 21.55. Think of 5 either side of the number 50 for the lower and the upper. We only need the upper. 13.4 would be 13.40. Think of it as that. Then the upper bound of that one is going to be 13.45. So the calculation we're going to do, 21.55 multiplied by 13.45. There is our calculation. I'm going to bring in the calculator to do that. Could do it in a long-winded fashion, but I'm not wanting to show you that skill in this particular video. These would normally be questions that are on calculator papers. Rest equals 21.55 multiplied by 13.45. Done everything correctly. I've got the answer of 289.8475. 289. I can't remember what it said. 8475. Okay, there we go. And that answer also would be in centimeters squared because it's a area. Now, squared units. 2. Rami. Rami's got a bag of bananas. A banana has an average weight of 183 grams to the nearest gram. So straight away, if you see this sort of question, to the nearest gram, that's been rounded already. You go, this must be a bounds or upper, lower limits of accuracy question. So a bag contains 8 bananas and the bag weighs 5.25 grams. I keep missing off the units. Grams to 2 decimal places. What is the minimum and maximum weight of the bag of bananas? Well, let's look at, first of all, what 1 is to the nearest gram. 183. Okay, to the nearest whole number. And let's think of what it could be if we want the upper and lower limits of accuracy. So the upper one, because we want we actually want both in this question, don't we? So that will be 183.5. Okay, and the lower one will be 182.5. Okay, sort of 0.5 either side of this number. And then we've got to take that and multiply by 8, and we've got to take that and multiply by 8 to get the weight of 8 bananas. Let's just look at the bag for a minute as well. So the bag itself weighs 5.25 grams. So 5.25, lower limit and upper limit for those. And what we get is, because this is to 2 decimal places, you can see it's already been rounded there. So that would be, stick a 0 on the end there. That lower one's going to be 5.245 or 5.245, and the upper one is going to be 5.255. Okay, and that's in grams, and that's also in grams, and that's also in grams. Okay, let's look at let's get our calculator. Let's do our lower limit of accuracy first. So just going to move that out of the way of the question. There we go. 182.5 is going to be multiplied by 8 first, because there are 8 bananas in the bag. That gets us 1460 exactly. And I'm going to write down what I did. 182.5 multiplied by 8 equals 1460 grams. And then I'm going to add on the smallest weight of the bag to that. So that's going to be plus the 5.245 equals. So we get final answer for the lower limit equals 1465.245. Okay, I can't squeeze the working out in for the last bit that I did there, but there we go. There's that. Now the upper limit is going to be pretty much the same thing, just with slightly different numbers. 183.5 multiplied by the 8 bananas that there are that could potentially weigh that. That's another 8 grams on top of what we had before, and then we're going to add on to that the highest weight, or the largest weight of the bag itself, 5.255, and that equals that number, 1473.255 grams. Okay, you can see why these are on calculator papers now, because there's a lot of faff with decimal numbers there, isn't there? But hopefully that sort of question makes sense now. You might have to write that as an error interval, but again, I've showed you that in a different video. Now, in the last one, Sammy, Sammy buys for 150 kilograms of plums. I shouldn't say 4. Sammy buys 150 kilograms of plums to the nearest 5 kilograms. Made loads of errors in this one. I'm so sorry. Plums cost £2 per kilogram to the nearest whole pound. What's the maximum amount of money Sammy could have spent on plums? Now, I think in this question we have to think about the money, side of things. I think that money could be considered continuous data, right? But money is actually a real world thing. So we actually have to consider it in our maths question here as discrete data, something that can be counted. Okay. And yeah, so let's have a look at this and see what we need to do. So 150 kgs to the nearest 5 kgs. So we're going to think of 2.5 either side of that. So that's 152.5 for the upper, and for the lower we're going to have 147.5. They thought of 2.5 either side of this 150. Plums cost £2.49 to the nearest whole pound. So the money is £2, and we're going to go with the lower one and the upper one. Again, we don't need the lower necessarily for this particular question, but I'm just working out to show you what I'm doing. Right, now that could be £1.50 to the nearest whole pound, couldn't it? That could have been £1.50. That would round up to £2, right? But this is the type of data it is. It couldn't have been £2.50 because that would have rounded to £3. So it could have been £2.49. Okay. And there's a slight annoyance to this question that I think that we'd have to pick up on. Now, I'm going to take the amount of money that he's could have spent on plums of £2.49. I'm going to multiply it by the upper bound of 152.5. So let's just type that into the calculator, move it over a little bit here so I can get the buttons. 152.5 and multiply by £2.49p. That equals that amount of money. So £379, and then we're going to have to round that money up, so 73p. Okay, tricky questions. Hope you enjoyed it. Like the video if you liked it. If you didn't, then don't worry. It's not the end of the world. I'll see you next time. Thanks very much.